Right now, as you are watching this, there's a pool of water sitting beneath the surface of the Pacific Ocean that is 9 degrees hotter than it should be, not at the surface where ships sail and waves crash. Underneath it, hundreds of feet below the waves, where sunlight barely reaches and the ocean is supposed to be cold and stable, a wall of heat the size of a continent is slowly rising toward the top. And when it gets there, it is going to change the weather for hundreds of millions of people. That is not a guess. That is not a theory someone posted online. That is what the actual data from NASA satellites and ocean monitoring buoys is showing right now, this week, in real time. We have been tracking the Super El Niño building in the Pacific for months now. If you have been watching this channel, you know the numbers have been climbing in a way that is hard to ignore. But with every new data update, the numbers keep pushing higher. And the latest round of data is, frankly, unlike anything we have seen during the development of an El Niño event in recorded history. But here is what actually made me stop everything and sit down to record this video today. In just the last few weeks, something else showed up, something separate, something thousands of miles away. A second ocean, on the other side of the planet, started heating up in the exact same way, at the exact same time, feeding into the exact same atmospheric pattern as the El Niño. 2 different oceans, 2 separate warming events, both firing at once, both aiming their energy at the same target, the jet stream that controls your weather. Scientists have a name for this. They call it a dual ocean engine. And it is one of the rarest and most powerful setups in all of weather forecasting. When 2 tropical oceans sync up like this and start pumping heat into the atmosphere together, the effect on global weather is not just doubled. It is amplified in ways that go far beyond what either ocean could do on its own. Let me put some numbers on this so you can feel how big this is. NOAA, the biggest weather and climate agency in the United States, just updated their forecast. As of their August 13th report, there is now a 95% chance that this El Niño reaches very strong levels by the end of this year. That is up from 81% just a month ago and 63% in June. The odds keep climbing and they keep climbing fast. But here's the number that really jumps off the page. There's now a 69% chance that this El Niño becomes the single strongest ever recorded since tracking began in 1950. Not top 3, not top 5, the strongest ever. Think about that for a second. There is roughly a 7 in 10 chance that what is happening right now in the Pacific Ocean has never happened this powerfully in the entire period of modern weather records. The 1997 event that flooded California and brought tornadoes to Florida? This could beat it. The 2015 event that they called the Godzilla El Niño? The current data is tracking stronger than that one too. 3 separate forecasting agencies from 3 different continents, NOAA in the US, the ECMWF in Europe, and the BOM in Australia, are all independently projecting that this event peaks at historic levels. When 3 modeling systems built by different teams using different methods all agree on the same conclusion, that should get your attention. And remember, that is just the Pacific. We have not even talked about the second ocean yet. That is coming. And when we get there, you will understand why this is not just another El Niño story. This is something different. Before we break all of this down, I want to hear from you. Drop a comment right now and tell me where you are and what your summer has been like. Has it been hotter than normal? Wetter? Drier? More storms than usual? I am genuinely curious because what you are experiencing on the ground right now is already being shaped by this event, even though we are still months away from its peak. And by the end of this video, you will understand exactly why your summer weather has felt the way it has. Now, by the end of this video, you're going to understand exactly what is coming and which regions are most at risk. But understanding what is coming is only half of it. The other half is actually being ready when it arrives, and most families are not even close. That is why I put together something called the Family Disaster Survival System. It is a complete step-by-step guide built for regular people, not survivalists, not preppers, just normal families who want to know they will be okay when the power goes out, the roads ice over, or a storm knocks everything offline for days. It covers everything from emergency food and water, to keeping your home safe in extreme cold, to a simple grab-and-go plan if things get serious. If this winter plays out the way the data is pointing, having a plan like this could make a real difference for your family. The link is in the description and pinned in the top comment. Go check it out. All right, let us get into this. Section 2, the monster beneath the surface. To understand why the next 6 months of weather are about to get wild, you need to understand what is actually happening right now in the tropical Pacific. And I do not mean in some distant, abstract, scientists are concerned kind of way. I mean right now, this week, in measurable, visible, off-the-charts data. The Pacific Ocean is the largest body of water on Earth. It covers more area than every piece of land on the planet put together. If you took North America, South America, Europe, Africa, and Asia, and laid them all inside the Pacific, you would still have room left over. So when something unusual starts happening in the Pacific, it does not stay local. The whole world eventually feels it. El Niño is the name for what happens when a big stretch of the tropical Pacific gets much warmer than it should be. It is a natural cycle that has happened many times throughout history. But here is the key thing most people do not realize. Not all El Niños are the same. Some are barely noticeable. Water temperatures go up half a degree, the weather shifts a little bit in some regions, and most people never even know it happened. Those are weak El Niños. They come and go without much drama. Then there are moderate ones. A degree or so of warming, enough to shift rainfall patterns in some areas, maybe cause some flooding in one region and drought in another. Noticeable if you are paying attention, but not world-changing. And then, every once in a long while, the Pacific produces something in a completely different category. An El Niño, so strong, it basically grabs the atmosphere by the collar and shakes it. One that rewires jet stream patterns across the entire planet, produces record rainfall in places that are normally dry, triggers droughts in places that are normally wet, and leaves a mark on global temperature records that shows up for years. Those are Super El Niños. And in the modern era of weather records, there have been only a handful. The monster events of 1982, 1997, and 2015 are the ones scientists always reference. They are the benchmark, the gold standard, the if it is as bad as one of those comparison that forecasters reach for when they want to communicate just how big something is. What is building right now in August 2026 is tracking to match or surpass all of them. Here is how it works, broken down as simply as I possibly can. Under normal conditions, the trade winds blow steadily from east to west across the tropical Pacific. These winds are like a giant conveyor belt. They push warm surface water toward Asia and Australia, piling it up in the western Pacific. At the same time, they pull cooler water up from the deep ocean along the coast of South America. This keeps things in balance. The west stays warm. The east stays cool. The atmosphere above sits in a predictable pattern. But sometimes those trade winds weaken. Sometimes they slow down. And sometimes they completely reverse and start blowing the opposite direction. When that happens, it is like releasing a coiled spring. All that warm water that has been piling up in the western Pacific starts surging east. It spreads across the middle and eastern Pacific like someone tipping a bathtub. And as it spreads, it heats the air above it. The heated air rises. And that rising air is like pulling on a loose thread in a sweater. One tug, and the whole pattern starts to unravel thousands of miles in every direction. Now here is what makes this particular event so extreme. And it is the part that most coverage misses. The real engine of this El Niño is not at the surface. It is hidden underneath. Deep beneath the waves, there is a massive pulse of hot water traveling through the ocean. Scientists call it a Kelvin wave. Think of it like a slow-motion tidal wave, except instead of height, it carries heat. It moves eastward under the surface of the Pacific, pushed by those reversed trade winds, carrying an enormous amount of thermal energy from the western Pacific toward the east. And the one happening right now is absolutely enormous. At its core, the latest data shows water temperatures more than 9 degrees Celsius above normal. That translates to over 16 degrees Fahrenheit, hotter than it should be at that depth. To put that in perspective, a normal ocean temperature change that gets scientists excited is maybe 1 or 2 degrees. 9 degrees is in another universe entirely. This underwater heat wave is the fuel tank for the entire event. It is what keeps this El Niño growing stronger week after week. As that warm water slowly rises to the surface, it releases its energy into the atmosphere. And that is what drives everything else. The storms, the temperature shifts, the jet stream getting yanked thousands of miles south. All of it traces back to this furnace underneath the Pacific. Right now, surface temperatures in parts of the eastern Pacific are already running about 4 degrees Celsius above normal. That alone would be noteworthy. But the fact that there is a massive reservoir of even warmer water still rising from below means this event has plenty of fuel left to burn. The surface anomalies are just the tip of the iceberg, or in this case, the tip of the boiling pool. The latest forecast runs are projecting a peak surface anomaly above 3 degrees Celsius in the key monitoring region later this year, which would officially make this one of the strongest, if not the single strongest, El Niño events ever measured. NASA satellites have already detected the signature of this event from space. The ocean is literally swelling in the areas where the warm water is pooling beneath the surface. The sea level in parts of the central and eastern Pacific is measurably higher than it should be, not because of waves or tides, but because warm water expands, and there's so much heat concentrated under the surface that it is making the ocean itself physically bulge upward. So that is what we are dealing with in the Pacific, a record-chasing heating event powered by an absolutely massive underground pulse of warm water being tracked by every major space agency and forecasting center on Earth, and projected to keep getting stronger through the end of this year and into early 2027. If that were the whole story, this would already be one of the biggest seasonal weather stories in years. But it is not the whole story, because another ocean just entered the picture. Section 3, the second ocean, wakes up About 7,000 miles west of where the Super El Niño is raging in the Pacific, there's another ocean, the Indian Ocean. It stretches from the coast of East Africa all the way east to Australia and Indonesia. It is the third largest ocean on the planet. And in just the last few weeks, it started doing something that made every weather forecaster on Earth sit up and pay close attention. A second warming pattern has appeared in the Indian Ocean. And it is not random. It is not a coincidence. It is directly connected to the exact same shift in the tropical atmosphere that is driving the Super El Niño. The World Meteorological Organization, the global authority on this stuff, confirmed it in their latest update. They specifically warned about the combined impacts of the Super El Niño and this Indian Ocean anomaly developing together between August and October, with effects rippling outward from there. Here is the plainest way I can explain what is going on. Normally, the Indian Ocean is pretty balanced in terms of temperature. The water on the western side, near the coast of Africa, is roughly similar in temperature to the water on the eastern side, near Indonesia. Things are even. Things are stable. But sometimes that balance tips. The western side starts getting warmer while the eastern side cools down. It creates a temperature gap across the ocean, like a seesaw where one end rises while the other drops. That pattern has a name. It is called the Indian Ocean Dipole. And when the western side is the warm side and the eastern side is the cool side, that is called a positive Indian Ocean Dipole. On its own, a positive Indian Ocean Dipole is interesting but not usually headline news. It tends to make Australia warmer and drier. It brings extra rain to parts of East Africa. It has some effects on the Asian monsoon. It is a player in global weather, but typically a supporting character, not the lead. What makes this moment completely different is the timing and the connection. This positive Indian Ocean Dipole is not developing in a vacuum. It is emerging at the exact same time as one of the strongest El Niños ever observed. And it is being created by the very same atmospheric shift that sparked the El Niño in the first place. Here is how that connection works. The trade winds do not just blow across the Pacific. They are part of a much larger circulation system that stretches across the entire tropical belt, from the Pacific, through Indonesia, and across the Indian Ocean. When those trade winds weaken or reverse in the Pacific, triggering El Niño, the ripple effect does not stop at the edge of the Pacific. It reaches across into the Indian Ocean too. Near Indonesia, the changing wind patterns cause the eastern Indian Ocean to cool down. Meanwhile, the western Indian Ocean, no longer being pushed by the same wind patterns, starts to warm, and just like that, the seesaw tips. The positive Indian Ocean Dipole is born, created by the same atmospheric rearrangement that is feeding El Niño. They are two branches growing from the same tree, two symptoms of the same enormous shift in tropical wind and heat patterns. And here's where this turns from interesting to pay attention to this right now. Each of these events, El Niño and the positive Indian Ocean Dipole, creates a zone where air rises strongly in the atmosphere. Over the warm central and eastern Pacific, air rises because of El Niño. Over the warm western Indian Ocean, air rises because of the positive dipole. In between those two rising zones, right over Indonesia and the water surrounding it, air sinks. It gets pressed downward by both systems at once. Think of it like squeezing a tube of toothpaste from both ends. The pressure in the middle, the sinking air over Indonesia, becomes incredibly strong and incredibly stable. And that is the key to everything. When that sinking air locks in over Indonesia, it acts like an anchor. It pins the entire global atmospheric pattern into place. It makes the pattern stronger, more persistent, and longer lasting than either ocean event could produce on its own. Think of it like this. If El Niño alone is a strong wind pushing a sailboat in one direction, adding the positive Indian Ocean Dipole is like adding a second sail and a current flowing the same way. The boat does not just go a little faster. It goes a lot faster, and it becomes nearly impossible to turn. That locked-in pattern then sends out what scientists call a wave train. It is basically a chain reaction. Alternating zones of high and low pressure ripple outward from the tropics, travel north through the mid-latitudes, and reshape the jet stream across the entire Northern Hemisphere. And here is a detail from the research that really got my attention. Scientists went back and looked at past winters when both a strong El Niño and a strong positive Indian Ocean Dipole were active at the same time. They compared what their computer models predicted would happen versus what actually happened in the real world during those winters. And what they found was striking. The real world was consistently more extreme than the models predicted. The actual storms were stronger. The jet stream shifts were sharper. The temperature swings were more dramatic. The atmosphere basically fed on this combined tropical energy more aggressively than the computers could account for. Think about what that means for right now. The forecast models are already projecting a dramatic, pattern-altering winter. And based on historical evidence, reality tends to overshoot those projections when both oceans are involved. That is not a reason to panic, but it is a reason to pay very close attention. The forecast data shows this positive Indian Ocean Dipole is expected to persist through fall and into early winter, running alongside the Super El Niño at its peak strength for months. The last time we saw a comparable pairing was the winter of 2023 into 2024. The event building now looks significantly more powerful. So what does all of this actually mean for you? For your fall, your winter, your travel plans, your heating bills, your safety? That is exactly what we are going to walk through now. And we are going to start with what is already happening this month, because the dual ocean engine is not waiting for winter to start making its presence felt. Section 4. From right now through winter. What is already showing up? This month, you do not have to wait until December to see the effects of this dual ocean engine. The atmosphere is already responding, and if you know what to look for, you can see it right now in August. Over the first half of this month, a stubborn area of rising air has been locked in place over the tropical Pacific, directly tied to the strength of the El Niño warming underneath it. That rising air acts like a pump. It forces air to sink somewhere else, and where it has been sinking is over the western and central United States. When air sinks, it compresses and warms. That is why parts of the western US and Canada have been running hotter than normal through early August. It is not random. It is not just summer being summer. It is the El Niño's fingerprint, already stamped into the pattern. By late August, forecasters expect a shift. The pattern is expected to swing back the other way for parts of the eastern US, with a temporary cool down as a low pressure zone builds over that region. If you are on the East Coast and you suddenly get a few days that feel more like early fall than late summer, that is the same system at work. As we move through September and October, the signal from the dual ocean engine becomes progressively clearer and harder to miss. Across North America, warmth is expected to build across the northern states and Canada, riding under a persistent high-pressure ridge. Meanwhile, the southern half of the country starts to see a more active storm track setting up, with above-average rainfall building across the Gulf Coast and southeast well before winter officially begins. Over in Europe, fall is expected to run warmer than normal across most of the continent, with a persistent flow of mild air from the south and southwest. Rainfall runs above average across Central and Western Europe as Atlantic low-pressure systems pull in wave after wave of moisture. Think of fall as the opening act. The main event is winter, but the opening act is already on stage, and it is already playing the same song. Before we get into the regional winter breakdown, let me set the right expectation. Seasonal forecasts work differently than your 5-day weather app. They cannot tell you that it will snow on December 14th, or that January 22nd will be 2 degrees below zero. Nobody can do that months in advance, and anyone who tells you they can is not being honest. What seasonal forecasts can tell you, especially when they have a strong, clear driver behind them like this dual ocean engine, is the broad shape of the season, the big patterns, the tendencies. Which regions will trend warmer, which will trend cooler, where the storm track will set up, and where the biggest risks are hiding. Right now, that broad shape is remarkably consistent across every major forecasting agency in the world. And the reason is simple. The drivers, the Super El Niño and the positive Indian Ocean Dipole, are so strong and so well understood that the main pattern is showing up clearly in every model that runs the calculation. So let us walk through this. North America, a winter of two halves. The single most important feature of this winter's forecast for North America is what forecasters are calling a split flow pattern, and it is going to create two completely different winters depending on which side of an invisible line you live on. Here is the setup. A big, stubborn dome of high pressure is expected to park itself over Canada and the northern United States and essentially refuse to move for most of the winter. Think of it like a giant boulder sitting in the middle of a river, the river being the flow of Arctic air that normally rushes south during winter months. That high-pressure dome is going to block most of that cold air from diving deep into the United States. It acts like a wall, a dam, keeping the worst of the Arctic cold bottled up across northern Canada and Alaska, rather than letting it pour down into the lower 48 the way it does in an average winter. For people living across the northern tier, up in Canada, the northern plains, the upper Midwest, and the Pacific Northwest, that translates to a milder winter overall. Not warm, not spring-like, but fewer of those brutal, sustained, pipes freezing, school closing cold stretches that can last for weeks at a time. Snowfall is expected to run below average, particularly across the northern Great Lakes and the Pacific Northwest, and heating bills should generally run lower than a typical year. I want to be clear about something, though, because I think it is important. Milder than average does not mean warm. It does not mean winter is canceled. You are still going to have cold weeks. You are still going to have storms. You're still going to need your winter coat and your snow boots. It just means the most extreme, sustained, bone-deep cold is less likely to reach you and less likely to stay as long when it does. Think of it as the difference between having a rough week of winter versus a rough month. Now, let us flip the map, because while the north gets a break, the south gets something else entirely. That same high-pressure dome that keeps the north mild has a flip side. It pulls the jet stream south, way south, and it supercharges it. The jet stream is a river of fast-moving air high up in the atmosphere. It is what steers storms across the country. In a typical winter, it runs across the middle of the U.S., sometimes dipping south, sometimes lifting north, pushing storm tracks around in a fairly variable pattern. In a strong El Nino winter, and especially in one with dual ocean forcing like this, that jet stream gets yanked south, and it gets much, much stronger. It becomes what amounts to a storm highway, a direct pipeline for moisture and energy, running from the Pacific Ocean straight across the southern United States. And this is not a subtle shift. This is a full-blown, active, moisture-loaded storm track expected to run from the Pacific coast across the southwest, through Texas, along the Gulf Coast, across the southeast, and up into the mid-Atlantic and the interior northeast. What does that actually look like on the ground? For Texas, the Gulf Coast, and the southeast, it means a wetter, stormier, and at times noticeably cooler winter than these regions usually experience. We are talking about repeated rounds of heavy rain, periods where cooler air pushes further south than normal, and a real genuine risk of winter storms, freezing rain, and ice events reaching areas that simply are not built for them. And that last part is what worries forecasters the most. Because the danger with winter weather is not always about how cold it gets. It is about where it gets cold. When a winter storm drops 6 inches of snow in Minneapolis, the city barely blinks. They have the plows, the salt, the experience, the infrastructure. They know how to handle it. Schools stay open. Traffic keeps moving. Life goes on. When that same kind of storm drops an inch of ice on Dallas, or 2 inches of snow on Atlanta, or freezing rain across central Mississippi, the result is completely different. Roads become skating rinks. Power lines sag and snap under the weight of ice, plunging entire neighborhoods into darkness. Pipes burst because the plumbing was never insulated for sustained freezing temperatures, and drivers who have never experienced icy roads in their lives suddenly find themselves sliding through intersections. The elevated snowfall potential this winter is not showing up where it normally does across the far north. Instead, it is concentrated across the southwest, the Central Plains, parts of the Midwest, the Mid-Atlantic, and the interior Northeast. That is a genuinely unusual and potentially dangerous setup for regions that do not deal with heavy winter weather on a regular basis. As the season deepens into January and February, the forecast models show this pattern not weakening, but actually getting stronger. The storm track digs deeper. The divide between the mild north and the stormy south gets sharper. Cold air surges riding along the southern jet stream become more frequent, even without a full-blown Arctic outbreak. There's also a wild card worth knowing about, and honestly, it might be the most dramatic part of the entire setup. Way up in the atmosphere, about 18 miles above the North Pole, there's a massive spinning pool of cold air called the polar vortex. Under normal conditions, it stays locked in a tight circle over the Arctic, spinning like a top. As long as it keeps spinning fast and steady, it acts like a fence. It keeps the coldest air on Earth bottled up near the pole where it belongs. But that spinning top can get knocked off balance. And one of the things that knocks it hardest is a Super El Niño. Here's why. When the tropics pump that much heat into the atmosphere, it does not just affect the jet stream at lower levels. It sends waves of energy surging upward, all the way into the upper atmosphere where the polar vortex lives. Those waves crash into the spinning pool of cold air like a bowling ball hitting pins. And when enough energy hits, the vortex wobbles. It stretches. Sometimes it splits completely in half. When the polar vortex weakens or breaks apart, something dramatic happens. Huge masses of Arctic air that were being held in place by that spinning fence suddenly have nothing keeping them north. They spill southward, fast, like water breaking through a dam. And when that happens during a winter that already has an active, moisture-loaded storm track running across the southern United States, the combination can be explosive. Picture a fire hose of moisture from the Pacific meeting a wall of Arctic cold pouring south from Canada. That collision is what produces the most extreme winter weather events, major ice storms, heavy snowfall in places like Tennessee, the Carolinas, and central Texas, the kind of events that shut down entire cities for days. There is an extra factor at play this year, too. High above the tropics, about 15 miles up, there's a wind pattern called the QBO, short for quasi-biennial oscillation. It is a cycle of winds that flips direction every couple of years. Right now, those winds are shifting into a phase that, based on past winters, tends to make the polar vortex more vulnerable to disruption. The timing of this shift means it will be at peak strength right as winter begins, which is exactly when the Super El Niño's upward energy waves will be hitting the polar vortex the hardest. Early forecast data for January 2027 is already showing signals that this kind of disruption could happen. It is too far out to confirm with any certainty, but the fact that the signals are showing up this early, while the El Niño is still growing, is exactly the kind of thing that keeps forecasters glued to the data week after week. If it does happen, it would turn an already active winter into something truly memorable. Europe, mild and wet, with a twist. The same dual ocean engine reshaping North America's winter does not stop at the Atlantic. Its effects travel downstream, cross the ocean, and arrive in Europe with their own particular flavor. The broad outlook for Europe this winter points toward what forecasters call amplified westerly flow. In simple terms, the winds blowing from west to east off the Atlantic are going to be stronger and more persistent than usual, dragging mild, moist ocean air across the continent week after week. For Central and Western Europe, Germany, France, the Low Countries, and the surrounding regions, this points toward a milder than normal winter with above average rainfall. Not dramatically warmer, but enough to make sustained cold stretches less frequent and widespread snow less likely at lower elevations. Southern Europe, Spain, Italy, and southern France should see a similar pattern. Mild temperatures overall with periodic rounds of wet weather, especially when individual storm systems dip further south than the broader flow would suggest. Northern Scandinavia, in the far northeast corner of the continent, retain the best chances for a proper, snowy winter, since they sit close enough to the Arctic boundary that cold pushes can still reach them even when the overall pattern is mild. But the interesting wrinkle in Europe's forecast, and one that might catch a lot of people off guard, is the outlook for the UK and Ireland. While the big picture favors mild and wet, the British Isles sit right in the zone where low-pressure systems can occasionally take a more northerly track. When that happens, it opens the door for colder air to sweep in from the Arctic or from the northeast. These events tend to be sharp and sudden. You might have a week of mild, rainy, sweater weather, and then overnight, temperatures plunge, the rain turns to snow, and everything freezes. So while the overall lean for Britain and Ireland is toward a milder, wetter winter, there is a genuine chance of periodic sharp cold snaps mixed in, potentially with snow at lower elevations during those episodes, even inside a broadly warm season. It is kind of the opposite of the US setup. In the US, the surprises come in the south. In Europe, the surprises come in the northwest. The global picture. While this video focuses mainly on North America and Europe, the dual ocean engine does not respect borders or continents. Its reach is truly global. Australia is facing one of the more concerning outlooks anywhere in the world. The combination of a strong El Niño and a positive Indian Ocean Dipole is essentially a 1-2 punch aimed directly at the driest inhabited continent on Earth. Both of those ocean patterns, working together, pull moisture away from Australia. They weaken the rainfall systems that normally bring water to the eastern and southern parts of the country. They push temperatures up, and they set the stage for exactly the kind of conditions that produce devastating bushfire seasons. Australian forecasters are already warning of an abrupt end to their current winter. Warm, dry conditions are expected to take hold through spring and intensify into their summer months. Reservoir levels will drop, vegetation will dry out, and the wildfire risk will climb. If you remember the black summer bushfires of 2019 into 2020, the setup heading into this Australian summer shares some uncomfortable similarities. The Indian Ocean Dipole is actually the bigger driver for Australia specifically. Because a positive dipole cools the waters near Indonesia while warming them near Africa, it directly reduces the moisture flow that normally feeds rain systems over Australia. When you layer a strong El Niño on top of that, the drying effect is amplified well beyond what either pattern would produce alone. On the other side of the Indian Ocean, parts of East Africa are expected to see the opposite problem. Above average rainfall is projected for Kenya, Somalia, and Ethiopia, which can trigger flooding, landslides, and displacement in regions that are already vulnerable. It is the same seesaw that is drying out Australia, just experienced from the other end. Coastal South America, especially Peru and Ecuador, is bracing for a very different challenge. The warm Pacific water sitting directly off their coast means heavy rainfall and flooding, sometimes severe, as all that ocean heat pumps moisture directly into the atmosphere, right on their doorstep. Past Super El Niño events have caused billions of dollars in flood damage along the South American coast, and the setup this time is no different. Southern Africa faces elevated drought risk. Parts of Southeast Asia will see shifts in their monsoon and rainfall patterns. Even global food systems could feel the ripple as growing conditions change across key agricultural regions. The fingerprints of this dual ocean engine are going to be visible on literally every continent over the next 6 months. What this means for you, specifically. Let me boil this down to practical advice by region. If you live in the northern US or Canada, your winter is likely milder and less snowy than average. That is good news for heating costs, commutes, and general quality of life during the cold months. But keep your winter gear ready. A mild leaning season still has cold weeks and storms. If you live across the southern US, from California to the Carolinas, take this forecast seriously before winter arrives. And take it seriously now while you have time, not in December when the first storm is already bearing down and every store is sold out of pipe insulation and space heaters. Check your pipes. If they are exposed or run along exterior walls, insulate them. It is cheap and it takes an afternoon, but it can save you thousands in water damage if temperatures drop below freezing for a sustained stretch. Make sure your heating system actually works. Run it now and find out if something is broken while repair companies still have openings on their schedule. Put together a basic emergency kit with water, blankets, flashlights, batteries, a charged power bank, and non-perishable food. Keep a separate kit in your car in case you get stranded. Think about how a major ice event or a multi-day power outage would affect your household. Do you have a plan? Do you know where your water shutoff valve is? Do you have a neighbor you can check on? These are not dramatic questions. They are practical ones. And the storm track setting up for this winter makes these scenarios more likely than in a typical year across regions that rarely have to think about them. If you are in the Central Plains, the Midwest, or the Mid-Atlantic, the snow and ice risk is elevated in a way that does not happen every winter. Stock up on basics before the season starts. Keep an emergency kit in your car. Watch the forecasts closely as fall transitions into winter. If you are in Europe, enjoy the milder season, but do not get complacent if you are in the UK or Ireland. Those periodic cold snaps can arrive fast and hit hard, and they tend to catch people off guard precisely because the rest of the season feels so mild. None of this is about fear. All of this is about being smart, about knowing what is coming and using the lead time to prepare instead of scrambling after the fact. How much should you trust this? Here's the honest answer. Seasonal forecasts are always uncertain to some degree, but they are most skillful when there is a strong, well-understood driver behind them. And right now, we do not have one strong driver. We have two. A potentially record-breaking Super El Niño and a positive Indian Ocean Dipole, both reinforcing the same atmospheric pattern. That is about as clear a signal as seasonal forecasting ever produces. 3 independent agencies, NOAA, the ECMWF, and the BOM, are all showing the same big picture. When different teams using different methods on different continents converge on the same answer, that is meaningful. The broad pattern, mild north and stormy south in the US, mild and wet for Europe, drought and heat in Australia, carries genuine confidence. What remains uncertain is the specifics. Which exact week a storm hits, how much snow falls in any one city, whether the polar vortex disruption materializes in January. Those details will fill in over the coming weeks and months as we get closer and the data sharpens. So treat this as your starting point, the foundation. And keep watching, because the picture is going to get clearer and clearer as fall arrives. So let me bring this all together one more time. 2 of the largest oceans on Earth are heating up in sync. The Pacific is building what could become the strongest El Niño in recorded history. The Indian Ocean has tipped into its own warming pattern that reinforces the same jet stream changes. Together, they are creating a combined atmospheric engine that is more powerful and more persistent than either one alone. The fingerprints of this event are already visible in this month's weather data. They are not predictions anymore. They are measurements. And over the next 6 months, that signal is going to grow. Fall will show the early signs. By winter, the pattern is expected to fully lock in, delivering a season that looks meaningfully different from what most of North America and Europe has experienced in years. The thing that makes this moment unusual is not just how strong the El Niño is, it is that we are seeing it this clearly, this far in advance. Most winters, the forecast picture does not come into focus until October or November. This year, the broad shape is already visible in August. That is rare, and it gives all of us something that is actually valuable in weather: time to prepare. We are going to be tracking every single update as it unfolds. New ocean data every few weeks. Updated model runs from NOAA, ECMWF, and the BOM. New signals on the polar vortex, the storm track, the Indian Ocean Dipole. All of it broken down right here on this channel as it happens. If this video was useful to you, hit the like button so it reaches more people who need to see it. And drop a comment below. Based on everything we just walked through, does this change how you're thinking about the months ahead? Or does it match what you were already expecting for your fall and winter? And one last thing. I said it at the top, and I will say it again here because it matters even more now that you have seen the full picture. If you do not have a plan for your family in case this winter delivers what the data says it could, now is the time to fix that. Not in November when the first storm warnings start rolling in. Now, while the shelves are full and you have time to think clearly, the family disaster. Survival System walks you through everything, step by step, in plain language. How to prepare your home, what supplies you actually need, how to keep your family safe and comfortable, even if the power goes out for days. It is built for families, not for people who already have a bunker in the backyard. If you have kids, elderly parents, or anyone who depends on you, this is worth looking at. The link is in the description and pinned in the top comment. I read every single comment. I will see you in the next update.